Hello, welcome back to our class again. Lesson number 1, real numbers, exercise 1.2. Up to 4 I explained, and this is the fifth sum. Check whether 6 raised to n can end with the digit 0 for any natural numbers n. Okay, 6 raised to n, the meaning you listen first. 6 raised to n means n is 1 coming 6 raised to 1 and 2 coming x raised to 2, etc. etc. Okay. So listen, if 6 raised to n taking, what is n? We are taken n is a natural number. As usual, I told you, in the place of n, 1, 2, 3, etc. given see x raised to 1, 6 raised to 2, 6 raised to 3, 6 raised to 4, etc. Okay. But first you see the factors of 6. Which are the factors of 6 coming? 2 and 3. The factors of 6 is coming as 2 and 3. Your question is that the number 6 raised to n can end in 0. So if any number, if ending in with the digit 0, it should be completely divisible by 10, then only possible. For example, I will give you 30, 20, 40, 50, 60, 70, 80, 90, 100, all numbers you take, those who are ending in 0, these all numbers are divisible by 10. Then only the last digit will come as 0. Okay, if any number end with 0, it should be divisible by 10. So it should be divisible by 10. I written the factors of 10, which are 8, 2 and 5. So those numbers should be divisible by 2 and 5 both. Then only possible. Okay, but see the 6 raised to n, you see 2 into 3, the whole raised to n. So that I have split and written 2 raised to n into 3 raised to n. Here 2, in the place of n you give 1, then 2 raised to 1 into 3 raised to 1 coming. In the place of 2, n is equal to 2, you give 2 raised to 2 and 3 raised to 2 coming. These, any of the numbers are completely divisible by 2 and 5 both. It may be divisible by 2, it may be divisible by 5, but it should be divisible by both 2 and 5. Then only the numbers are divisible by 10. Then only the last digit 0 you will get. Last digit is 0, what is the meaning? Unit place digit is 0. Okay. So here in this format, any numbers coming, it is never divisible by 2 and 5 both. Therefore what you can say, it is never divisible by 10 also. Therefore what you can say, this type of numbers never ends with a 0. So 6 raised to n cannot end with the digit 0. Okay. For your understanding, I have given some examples downside. See. 30. This is only for your understanding, not to write in the answer page. Okay. 30 is equal to how much written? 2 into 3 into 5. Here see 2 and 5 both coming in. And here 2 square into 2 square means 4. How is coming? 4. 4 into 3, 12. 12 into 5, 60. Okay. Here also 2 and 5 coming in. And 40 you see. Here also 2 and 5 coming. So these all numbers are ending in 0 now. Here all factors which are they coming, 2 and 5 both coming. Then only it can be able to divide by 10 completely. Okay. Go to the next sum. Explain why. Now question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. You know what is composite numbers and prime numbers. Prime numbers means the number having factors, the number and itself, the number and one itself having, then we are calling as prime numbers. 2 is a prime number, 3 is a prime number, 5 is a prime number. Its factors are 5 and 1 only, 3 and 1 only, etc. etc. So here we have to say that they are composite numbers. See here, this is a term and this is another term now. From these two terms, I taken 13 common outside. 13 common outside taking, what is here coming? 7 into 11 plus 1. 7 into 11, how much coming? 77. 77 plus 1, how much coming? 78. 13 into 78. Enough. This do not need to multiply and write. It is not compulsory. I simply written here. Huh? So 13 into 78 taking itself, we can see it's a product which number coming. It has factors not only the same number and 1. It has factors. 13 is a factor, 78 is a factor, 2 is a factor, etc. So This type of numbers what we are calling composite numbers. It has factors other than the number and 1 itself. So 1014 has factors 13 and 78, etc. Therefore it is a composite number. Okay, more factors coming, it is composite number. Here this number having this same number and one only factor, then we can say it is prime. But it has factors 13, 78. Again 78 you can find out the factors 2, etc, etc. Okay, therefore it is a composite number. Next sum also same method we are doing, very simple it is. Here also see same. This whole one single term and this is another term. What is common? 5 common, 5 I taken outside. Then what is remaining? 7 remaining, 6 remaining, 4 remaining, 3, 2, 1 plus 1. So this much you multiply, how much? 1008 plus 1. How much coming? 1009. So this number, it's a product, how much coming? Product I didn't return, but the product is coming as 5045. So that number is also a composite number because it has factors 5 and 1009 factors coming out. It has other factors coming. So it is also not a prime number. So it is a, what type of number it is? It is a composite number. Okay. Clear now? Very simple type of sums only. Now, next question number, you also take a question, textbook take, and question number 7, read it. I written the question even though you read it. So what is happening here? There is a circular path around the sports field. Okay. Sonia and Ravi, though 2 persons are there. The 2 persons takes around. So see, for Sonia takes around 18 minutes taken for 1 round. And while Ravi taken how many minutes? 12 minutes taken. Okay. Suppose that. Okay. Question you make it clear. Sonia takes how much time? 18 minutes for 1 round. Ravi takes how much time? 12 minutes for 1 round. Your question is that after how much time both the persons are meeting at the same starting point? That is the question. They both are running in the same rotation and same direction. After how many minutes will they meet again at the same starting point? Okay. For understanding this one, I drawn a diagram last. You see the diagram? See here. See here. Sonia, how much minute? First round. First round, how much time taken? 18 minutes. So starting from here and ending here. 1 round completed now. 18 minutes. And again second round starting from here and ending here. How much time taken? 36. And again starting third round starting and ending here. Starting point coming after how many minutes? 54 minutes. And again starting from here and ending here, how many minutes? 72 minutes, etc. Same way Ravi also taking round around that field. Okay. First round, see here, starting from the starting point and running and coming back and reaching here after 12 minutes. Again starting and coming back to the same position. Again 12 minutes taken, no. So previous 12 and this 12, how much coming? 24. Again third round completing after again 12 minutes. See here, after third round 36 minutes completed, they reached there. Ravi reached there. Okay. In such a way, fourth round again completing, so that after again 12 more minutes completed, the person reached here. At 48 minutes completed, fourth round completed, then how much time covered? 48. So see here, first round, this is the second round, and this is the third round, and this is the fourth round. Okay. Our question is that after how many minutes both the persons reaching in the same point? See here, after 36 minutes completed and after 36 minutes completed, both they are here 36 minutes completing, they will reach there, and then 36 minutes again completing, they will reach here. How many rounds completing, that is not asking. After how many minutes both the persons will reach in the same starting point, that is your question. Actually, what is this one? This is multiple now. 18, 36, 54, 72 multiples only. And what is this one? 12, 24, 36, 48 multiple only. So what is this one? They are the least common multiple. Okay. So now go to the previous page. You see, I written here all the points. Now you understood the sum. time taken by Sonia to drive one round of the field of 18 minutes. Time taken by Ravi to drive 1 minute around the field at 12 minutes. So the LCM of 18 and 12 minutes gives the exact number of minutes after when they meet at the same starting point. Okay, that is the question. So for find after how many minutes both the persons are reaching in the same starting point, how you will find out? We will find out the LCM of this 18 and 12. So LCM of 18 and 12 already you know 18 factors I written and 12 factors I written. So what is your answer got? So what is LCM of 18 and 12? Highest factors with the highest index. The factors here 2 and 3 are already common also. Among these 2 factor with the highest index, here also 3 factor with the highest index. So 2 square how much coming 4 and 3 square how much coming 9. So 4 into 9 how much 36. So that is your answer. Clear? So actually you want to know the concept only here. LCM how finding out very clearly you know it. So then last conclusion, right? Therefore they will meet again at the starting point after how many minutes? 36 minutes. Okay. Exercise 1.2 over. Now we are going to learn many theorems based on irrational numbers. First of all, we will revise what is meant by irrational numbers. Very clearly you know it. Numbers which cannot able to express in the form p by q, where p and q are integers and q not equal to 0 are called irrational numbers. Clear now? Which are the examples? 2, 3, root 2, root 3, root 5, etc. are the examples. And now I will explain you one theorem, theorem number 1.3, very important theorem for doing theorem number 1.4. Here in this 1.3 theorem you need only the statement. Okay, so listen here the statement. Let p be a prime number. What is p? P is a prime number. Prime number you know which are the prime numbers? 2, 3, 5, 7, etc. are called prime numbers. Let p be a prime number. If p divides a square, then p divides a. Very important example for understanding the theorem number 1.4. You need there. So let p be a prime number. So understood the meaning? P be a prime number. If p divides a square, p dividing the square of any number, then surely that p divides the square root of the number. That means a. Understood? So example listen here. Example understanding you will get a clear idea. See here what teacher written. If 3 divides 9 square, surely you know 3 divides 81. So 81 divided by 3 possible? No. You can divide 81 by 3. 3 the symbol is divides. 3 divides 9 square. That means 3 divides 81. The meaning is that 81 is divisible by 3. 81 is divisible by 3, no? That is 9 square is divisible by 3. Then what we can say? Very clearly we can say, see here, p divides a square. P divides a square. Then what we can say? P divides a, the square root of 9 square. What is 9? Then 3 divides 9. It is very clear, no? 81 is divisible by 3. Surely 9 is also divisible by 3. See the example. If a prime number p divides a square, a is any positive integer. P prime number, that is must there. If p is a prime number, if p divides a square, then p divides a. See the second example also. In such a way, many examples you take and see. Here 2 divides 6 square. Dividing or not, you say 36 is divisible by 2, no? Then what will happen? This 2 divides the square root of 6 square. That means square root of 6 square, what is coming? 6. Therefore 6 is divisible by 2. Now you connect with your theorem. If p divides a square, then p divides a. Correct, no? Yes. If 2 divides 6 square, then 2 divides 6. Okay, understood the theorem properly now? Okay? Okay, bye. Then we will meet in the next class. Okay? Bye.